Hi viewers, this is Sri Ramulu. So today's topic is growth of charge, not current. Sorry, here it is not current. Growth of charge. Okay, friends, growth of charge. So growth of charge in capacitor-resistor circuit, or it is also called as CR circuit. Okay, growth of charge in capacitor-resistor circuit or CR circuit. Now, consider a circuit containing resistor R and a capacitor C, a two-way key and a battery of EMF connected in series as shown in figure. So in the figure it is shown that is a two-way key. That two-way key is called Morse key. Okay friends, now see here, when K is connected like this, then what happens? This circuit will be closed. That means this circuit contains a battery. So battery can give the charges, and main use of a capacitor is to store the charges. So here charges flows. That is why heading is charges I have written instead of current. Okay, so heading above heading just now I have changed. Okay, but if you connect like this, then what happens? No battery is there. Here discharging will takes place. When a K is connected A to A, then charging will takes place, and it is above, discharges will takes place. Now, when switch K is connected to the charging of condenser takes place until potential difference across the plate of the condenser becomes E value. So when it becomes a maximum voltage, then it stores the maximum charges. When K is connected to like this downside A value. Okay. Now let Q be the charge across the condenser plate at any instant t. The potential difference between the plate will be Q by C. This acts opposite to the applied EMF E, which acts Q by C. So Q by C is a voltage developed across capacitor only. So what it will do, it can oppose the current charges to increase. Okay, this acts as opposed to the applied EMF. So effective EMF at any instant t will be equal to E minus Q by C. E minus Q by C. Why it is Q minus Q by C? It opposes the growth of charge, which is minus Q by C opposes the growth of charge, and so therefore effective will be E minus Q, means E is a voltage across E and minus Q by C is a voltage across C. So effective or resultant voltage is E minus Q by C. According to Ohm's law, this should be equal to resistance and current at the instant t, that is Ri. So that is equal to Ri. So its product, this value is equals to product of resistance into current according to Ohm's law. Okay. Now what we have to do? So change this whole equation into charges only, but here we have the current equation. So change it, and E value also. But we know that E is equals to Q naught by C, where Q naught is the maximum charge of the battery. Okay. Okay, now next, Q naught by C is equals to Q by C into, generally above here what you have here, I you have. I value is dq by dt. So in the place of I it is substituted. And among these two things, C is a constant, take it, yes taken, and bring R is this side, become RC, and this Q naught minus Q this side, okay, dt is this side, right. So here separated like this. So dt is taken this side here, and this bracket is taken down, okay, and R also taken this side, so it is become here. So you know the mathematics. Integrating above equation, so both side integrate it, right, then what you get? You get like this. Okay, and after integration it is a T by RC, and a constant is taken here. Why? Because why we have to take the constant when we integrate on either side, both side. And see this equation minus this one. Why? Its differentiation is above without minus, so that is why minus is taken. Okay, so if you differentiate this one above, you can get minus value. Where a is called integration constant, to get a value we have to apply the initial conditions. What are the initial conditions? Before starting the charging, charges is become 0, so substitute these two values here, then what do you get? You get like this. So in the place of t 0, in the place of q also 0. Okay, so then a value we got this is, take this a value and substitute in the equation 1, in the equation 1 here. Okay, in the place of this, now equation becomes like this. Okay, it is, and so in the place of a it is substituted, take this value and write this side. Yes, it become minus, both side multiply with minus, it is minus plus it becomes minus, so like this. Now it is log a minus log b form, so log a minus log b form, we know log a by b. Yes, log a by b is also written. Okay, now write it into exponential form. So it is exponential form when log y base e is equals to x is there, then write x value in the power of y in the power of e and make it to equal e to y. So like this, y is equals to e power of x, same formula is implemented here. Okay, and here separate them, separated. Okay, it will become 1. Now this bring this side and bring this side. Okay, then it is the equation, and a q naught this side. So this gives the equation of growth of charge. So growth of charge, charges growth increases how? Exponentially. Okay, that is let equation 2. So equation 2 gives the charge in the circuit at any time t. It is obvious from the equation when, so at what time, so this one what it indicates, at what time the total the capacitor can charges to maximum value. So to know that, so substitute q is equals to q naught in the above equation. In the place of q is equals to q naught substituted, and it is multiplied inside, and bring this is this side. Okay, sorry, it is not changed. Okay, here also it is a q naught, it is also q naught, q naught gets cancelled. Okay, not changed. Okay, so it is also q naught, it is also q naught, so both are get cancelled, it is 0. Okay, and a q naught bring this side is 0. So this term is 0 means when when exponential power infinity is 0, then only we get that value is 0. So that means when at time t is equals to infinity, then only this term is 0, this term. So t is equals to infinity. Hence the charge never attains the value q naught, but it approaches it asymptotically, unexpectedly. Okay, not it not increases slowly, it cannot increase rapidly, it changes, it cannot moves along with the time. Okay, its wishes as wish when time t is equals to RC. So in the above equation substitute in the place of t RC, RC cancel, e power of minus 1, and write it is like this, take LCM, and then this is the equation. Why? E value we know, that is the E value is how much? 2.718 substituted here, and we may get this value by doing simplifying this. Thus after interval t, it is generally t is equals to RC. So in the place of t, lambda is substituted, lambda is called a time constant of RC. Charges reduces to value which is 60% of maximum charge, 63% of maximum charge. So 63% of maximum charge is only, that means charges can grow up to 60%, 63% is only, the remaining 30 to 37% want to grow, it takes infinity time. The value of RC is called time constant, it is denoted by lambda. So that is why here lambda is equals to written. The equation 2 can be written as so like this. So in the place of t, in the place of in the place of RC, simply lambda is substituted here. Okay. Next equation, the rate of growth of charge. So that means equation 2 can be, equation 1 can be differentiated. Okay. So in multiply first it inside, it becomes like this. So definition of maximum value means any maximum value or minimum value becomes constant. So constant definition is 0. Okay, so exponential term differentiation we know. So it is minus 1 by RC into T is there. So minus 1 by RC into T means the T product whatever you have, right, it is before this. So it is written like this. Now already minus is there, minus into this minus become plus Q naught into e power of minus T by RC. Okay, and here Q naught by it is see we can write it is from the equation 1 like this. So it is from equation 1 only taken. So finally we write like this. So if you want to see the equation, what is equation 1? Equation 1 is Q is equals to Q naught into 1 minus e power of minus T by RC, actually RC. From this we can write equation like that, and in the place of this we can substitute Q naught minus Q by RC. So above equation gives rate of growth of charges. Okay friends, so this is our rate of growth of charges. So don't forget this video watching till the end, and please share this video to your friends also. But before that, please make it correct current in the place of current, write charges only. Okay friends.